So one of the most important theorems that you're going to learn in calculus is something called the intermediate value theorem. We often abbreviate this as the IVT. Right, so if you're talking to anyone who knows calculus and you say IVT, they're going to know you're talking about the intermediate value theorem. So what this important theorem tells us is that if f of x is a continuous function on a to b, so something like this, so we say this is a, this is b, I don't know. Right, maybe something like that. Could look like anything in between the points, right? Just a continuous function. It says then if d is any number between f of a and f of b. So we have f of a here and f of b up here. I don't know, maybe we'll let d be here. Right, any number in between. So it's just somewhere on the y-axis in between them. If those things are all true, then there exists a number c in a to b. So an x value between a and b, where f of c is equal to d. And there's at least one of those numbers. Right? So if we trace over from D, it traces back down and we land back inside of our interval between A and B. So all it's saying for the intermediate value theorem is basically like it hits every y value between f of A and f of B. So if you pick any y value between f of A and f of B, there's at least one point in the interval where there's an x value that gives you back that y value. There's at least one point in that interval where the function equals that value. That's all it's kind of saying. So let's put it to the test here. So one great way to use the IVT is to show that a function has a zero, and it's especially great for functions that you can't solve algebraically, but you need to know that maybe there's a zero in between those 2 points. So we're going to use the intermediate value theorem to prove that f of x equaling x cubed plus 2x minus 1 has a zero on 0 to 1. So because f of x is a polynomial, we know f of x is continuous. So the first thing we're going to say is f of x is continuous on the interval from 0 to 1, right, since f of x is a polynomial. And polynomials are continuous everywhere. Right, so whenever you're asked to use a theorem, or even if the question doesn't like explicitly say use this theorem and you know you're going to end up using a theorem to like justify your answer, you want to make sure you like state that the conditions of the theorem are met. So the other condition of a theorem is that the d value, the value that you're looking for, is between the y coordinates of the endpoints. So we need to find f of 0 and f of 1. So f of 0, really easy to compute, right? That's going to be -1. And then for f of 1, that's going to be 1 cubed plus 2 times 1, which is 2 minus 1. So we're going to end up with 2. All right, so since f of 0 is less than 0, which is less than f of 1, right? So we're looking for a 0, right? So 0 is between the y values of our endpoints, and f of x is continuous. Right? By the intermediate value theorem, f of x must have a 0. It could have more than one 0, but it has to have at least one 0 in that interval. Must have a 0 in the